Hello, today we're going to take a look at multiplying 2-digit by 2-digit numbers using the area model, which is the primary strategy that we are using in 4th grade to solve 2-digit by 2-digit multiplication. So the problem on the screen, 56 times 72 is what we'll be solving today, and you can see that 56 is a 2-digit number and 72 is a 2-digit number. I have made a list of vocabulary words that we have been using at school as we work through the process. And those words and knowing what these words mean and how they interact with the problem is very important in 4th grade, and it helps cement the understanding for your 4th grader. So area model, product, factors, decompose, and partial products we'll be talking about as we go along today. And at the end, we'll be checking back in to make sure we know that we've identified all of those parts for you. All right, so we're going to get started with the area model, and that is basically a rectangular model, a drawing that will represent the parts of the multiplication. The area model here is very similar to what we've already done with 2-digit and by 1 digit and 3-digit by 1 digit. But in those instances, we have done area models that look like this. We have one row with 2 columns for a 2-digit number, 3 columns for a 3-digit number. Here, because we have a 2 by 2, what we need to do is create an area model that has 2 rows. These are our 2 rows, and it has 2 columns. That way that we will work out every part of the multiplication that we need to solve this. And the reason that we are solving it with an area model is so that the students understand all of the numbers that are being combined in a problem like this, and they can have a real visual representation of it. Again, we're very heavy into using our place value knowledge to help us multiply. Also, we don't know 56 times 72 off the top of our heads in a snap. It's not a fast fact. So of course we need to have a strategy to be able to solve that, and bringing it down into equations that we do know quickly helps us solve the problem, and that's really what we're doing. We're breaking it down into easier to work with chunks. So we're going to start by decomposing the 2 factors. 56 and 72 are factors. They will be multiplied together to make our product. So when we decompose, we look at the place value. Our 5 is in the tens. So just like we did with the other models, here we have 50 plus 6. And here we have 70 plus 2. We've talked a lot about, sometimes you'll see kids decompose 56 into 5 plus 6. Well, if you add 5 plus 6, you get 11. 11 is not 56. That's a much different value. So we want to be really careful that we're using the value of each place. Then what we need to do after we decompose is we label the parts of our area model, the length and the width, with our decomposed factors. So 56, and it doesn't matter what side I put 56 on. I could put 56 as the width or the length. 56, and then 72 becomes my other factor up on the top here. So I've also encouraged some kids to go ahead and just finish labeling the whole area model. They don't really need to, but you'll see in a minute. It gets a little tricky when we have these double-decker rows, but if I know that this side, this section from here to here is 50, I know that this is 50, I know that this is 6. I know that this bottom section would measure 2, because area, we're really finding a measurement of how many square inches or square units cover the inside space. So if I have all of these labeled, I just remember where all of my sides are for length and width, and that helps some students be more accurate and not make silly mistakes with their area model. So then we go ahead just like we've done before, and we're going to find the area of each rectangular box. The area of this box by length and width, the area of this box, length and width, this box and this box. And those 4 boxes, those 4 areas, will make up our partial products. We don't have the final product yet. Each box represents a part of the final product. So here we're going to do 50 times 70. We're going to box the 2 zeros I have, so we can just focus on 5 times 7. Knowing 5 times 7 helps me solve 50 times 70. I know that 5 times 7 is 35. But I actually had 5 tens and 7 tens. So if I have 35 tens, I actually have 5 tens times 7 tens, and that 10 times 10 becomes 100. So what we can do, we know that there's a pattern when multiplying by tens and hundreds, and there's a pattern in the zeros. So because I have 2 zeros, those 2 zeros then go after the 35, and my actual total is 3,500. Now I'm going to go ahead and I'm going to say, you can go work across this way or this way, doesn't matter. I'm going to say 50 times 2. I can also look at this side, 50 times 2. Box the 0 so I can focus on 5 times 2. 5 times 2 I should know quickly is 10. And I can add that 0 back on to get the real value of 50 times 2 is 100. Working down to the third rectangle is 6 times 70. So 70 is labeled here so I can see it clearly. If I had not labeled the 70 here, I try to get the students to kind of go, oh, 6 goes with this box, and then I go all the way up to the top to see my measurement. That's 70. Focus on 6 times 7. 6 times 7 is 42. Add my 0 back on. 6 times 70 then is 420. Here I have 6 times 2. An easy fact for us, hopefully, 12. So now I have 1, 2, 3, 4 partial products. By breaking it down in place value, I have been able to work more quickly with some numbers that are in the tens and the hundreds, or some very easy single digit multiplication. Then we need to combine our partial products back together to get our final product. So we are going to go over here and set up our addition equation, just like we did with 3 digit by 1 digit, being very careful that all of our ones are lined up, and all of our tens, and all of our hundreds, and all of our thousands. 420 and 12. That's a 2. 2 plus 1 is 3. 5 plus 1 is 6, plus 4 more is 10. I'm greater than 10. I need to regroup to the thousands place. 3 plus 1 is 4. My final product of 56 and 72 is 4,032. We're also going to be working on a little bit today, just kind of estimating for reasonableness. Like, is this a reasonable answer? How could I decide that? So one of the ways that we can do it is we can take our 2 factors and round them to the nearest 10, and then multiply those together and see if that product is close to our actual product. If it is, then you can say that it is a reasonable answer. It's not going to 100% check for accuracy, but it makes sure that you are on the right track. So let's try that. So if I were to think about what 1056 was closer to, is it closer to the 50, or is it closer to the next 10, which would be 60? Well, because it's greater than 55, it's 56, that's closer to the next 10 of 60. 72, would that be closer to its current 10 of 70, or the next 10 of 80? Well, 2, because 2 is less than 5, the midway point, it tells us that it is closer to 70. So using that box the 0 strategy, I can do an estimate really quick. 6 times 7 is 42. Add my 2 zeros back on. My estimated answer is 4,200. That does look in the ballpark, in the area of 4,032. So I can kind of go on pretty confidently that my answer is a reasonable answer. We're going to do a quick vocab check and make sure you understand where all of these vocabulary words match up with our model right here. So the area model is called an area model right here because ultimately we are finding and solving for the area of each rectangle using the length times width formula. Product is the answer to any multiplication equation. 4,032 is our product. Factors are the two numbers that you multiply together. 56 is a factor and 72 is a factor. Decompose is what we did when we broke down our factors into their place values. Expanded notation, that's called when you make an addition equation with the place values. And our partial products are these four products that we found that when we combine them make our final full product. They are part of the product. So that is what 2-digit by 2-digit multiplication looks like with the area model. Hopefully that gives you a good idea as you are possibly practicing at home. If you are finding that your fourth grader is struggling a little bit when you see them working on their homework tonight, it is very easy to just pull out a scrap of paper or a whiteboard, create your own problems, and just keep practicing. This is really just a skill that needs to be practiced. And also, all fourth graders will be getting, let me find it real quick here, a multiplication chart that looks like this. So for those fourth graders who are not 100% fluent with all of their facts, their single-digit facts, or up to 10s, 11s, and 12s, this will help them a lot. So if you're getting to right here, if you are looking at 6 times 7 and you don't know what 6 times 7 is quick, then you are going to have to count by 6s or count by 7s. And that's going to take you a little bit more time to solve this problem. Yes, our goal is that students do know what 6 times 7 is pretty quickly. But right now we want them to kind of focus on the 2-digit by 2-digit and the strategy and not really get caught up in solving 6 times 7. So this is going to be a tool to help bridge the gap until they get those facts mastered. So this can go back and forth to home. You can easily find one online and print it yourself so that they can look at this really quick. And when they get to 6 times 7, they can look and go, oh, 6 times 7 is 42. Oh, it's 42. I've got 1 0, it's 420. So that's just a tool. We'll be using it in class to help us, and a suggestion for at home too. All right, have a great night.